Hi, how are you doing today? This is the talk on writing modular encapsulated Redis code. My name is Jim Nelson. I work at the Internet Archive based here in San Francisco. I'm here to talk today about some experiences that I've had writing client code for Redis and techniques I've used to work around some of those issues. I'll be going for about 40 minutes and then have a little Q&A afterwards. All right, sound good? All right. Just a brief introduction of the Internet Archive. It was founded in 1996 in San Francisco. We are an archive of digital and physical media. We archive the web, we archive books, both print and digital, music, film, software, and more. Currently, our digital holdings are over 35 petabytes and counting. We keep that in paired storage. It's all located here in San Francisco, and another copy is across the bay. We experience about 1 million users per day. That's both logged in people and just random folks that just wind up clicking on a link and landing on our site. The key collections and services for the Internet Archive, probably the most famous is the Wayback Machine. We have over 20 years of web archives held here. We've been in the news a little bit lately. I'm not going to answer any questions about that. I'm sorry. That's for the lawyers to figure out. The Grateful Dead live concert collection, we have according to university professors, we've actually heard from them, we have recordings of every live Grateful Dead concert from 1966 to I don't know when. And I know what you're saying, Jim, that's pretty incredible. There's a university professor who studies the Grateful Dead, but it's true, I'm not making that up. And then one of the other things we have that's pretty well known is emularity, which is in-browser emulation of various software, 8-bit software like Apple, Atari, IBM, the Mac, and just recently we added an entire stash of emulation for handhelds like Speak and Spell. All of that is backed by a number of different pieces of software we use to maintain our infrastructure, but Redis is a key part of it. The part that I work on most extensively is caching and directory lookup. Everything in the archive is stored in what's called an item. It's like a bucket or a bin, and every item has to be accessible at a moment's notice. And that all goes through a 10-node sharded Redis cluster. The sharding is performed client-side via consistent hashing. We use the Redis PHP library for that. Each node is supported by 2 replicated mirrors that act as slaves, and they can fail over at any time. And then we have also some specialized Redis instances also used throughout the Internet Archive, including the Wayback Machine, search, administrative and usage tracking, and that kind of thing. But today, I'm not going to be talking specifically about how we use it, but more about some issues that I've encountered coding to solve some of our problems. So a few things just to get started here. This isn't a beginner's course. I'm assuming you've written Redis client code already. You don't need to know the exact details of the Redis protocol, but you should have some knowledge of how Redis works. Things like it's single-threaded, the different data types it supports, strings, hashes, sorted sets, and the fact that it supports transactions, the multi-exec commands. This presentation uses PHP sample code, and we're using Redis, which is a PHP client library. But I'm more talking about concepts here. The concepts should work in other languages and with other clients. So don't think this is like a PHP-only session. So Redis rocks. This is what I said when I first started using Redis. Baby, where have you been my whole life? Quick, quick, quick. It's quick to code, it's quick to debug, quick response times, quick to model data. I just felt like it was at the keynote this morning, and so you get that instant on feeling when you use Redis. You could just jump in and go with it. I like its logical, well-defined command structure. I love the atomicity features. I love the fact that it's about flexibility over rigor. I felt that by learning a handful of some very straightforward concepts, I had picked up on Redis quite quickly. And that I liked, and that I don't want to take away when I work with it. I don't want to build more layers of abstraction to prevent that or keep that away from me. But there are issues. So my affair with Redis is complicated, as in Facebook is complicated. So often in our code and in other code that I've seen, I find application code mixed with data modeling code. Another way to put it is that the difference between the data logic and the business logic, it gets blurred. I come from a world of relational databases, and in a well-defined application, there's usually a hard line between that. And with Redis, there were a lot of reasons we couldn't just do that, and I'll be showing some examples. Often, when it says relational data, I probably should just say related data. Is often sprayed across separate Redis buckets. You keep your data in all these different keys, and in the case of like a 10-node cluster, it might be across different machines. And I found that there was really no clean way with the Redis primitives to normalize or deserialize complex objects if they're sharded across keys. Imagine, for example, if you have an object in your code base that's based on a number of different data points that are stored all over Redis, and you have to assemble all of them to initialize that object. I found that there was not really a clean way of doing that. And most of all, I found that performance considerations would often trump clean coding practices. That often there was sort of a need to reduce all activity to a single round trip or to maximize operations per transaction. And that would destroy modularity. We'd wind up having to take a lot of unrelated code and pack it together in order to make sure that on the wire it was just one request up and one response back. And I think the problem is that when you look at Redis, it looks a lot like a collections framework, like something that's bundled with Java or bundled with C#. I want to use just lists. I just want to use sorted sets. I want to use hashes. And with a classic in-memory traditional collections framework, you don't worry about these sorts of transaction or network latency issues. And so I was just trying to search for a way, how can I write my code so it looks more like a collection framework without losing the performance that we needed. And what I felt like was missing was all the things that I know and love about designing clean code. It was missing modularity, it was missing readability, and most of all, it was missing encapsulation. And that's why that's in bold in the middle. I think these are all words we're probably all familiar with, but just to make sure we're all on the same page, I'm going to just bring up a quote here from Martin Fowler. It's a guy I really like. I think he's has quite a bit of wisdom. You might check out his website. He defines encapsulation as, encapsulation says that a program should be divided into modules that hide data structures behind an interface of procedure calls. The purpose of this is to allow you to change the underlying data structure without causing a large ripple effect across the system. And we've all done this. I mean, we've all seen this. Either you've walked into a project and you had to deal with this, where the data structure changes and you find yourself having to change code all throughout your program, your application, because it was affected by that. So it's one thing when the data structure is in memory. It's just a record or it's an array that's stored behind, say, a class. It's another thing when your data structure is stored on a massively distributed cluster or a system or across the network. How do you hide that from the rest of your implementation? So briefly, my time is limited, but I'm going to go quickly through just a couple of points to make sure we're all on the same page. Basically, Redis and most Redis clients offer different modes of operation. There's an immediate mode, a pipeline mode, transaction, and then what is sometimes referred to as an atomic pipeline. So just briefly, I want to go through these. Immediate mode is you send one command, you receive one response. And that's it. There's really nothing more to it. So here you see some PHP code here where we instantiate a client object. We do a GET, and we get back the name. We do another GET, we get back the user's email. We do an increment, and we get back the login count. That's it. All three of those represent round trips to the server, however. So you get what's often called pipeline mode. Pipeline mode is you schedule commands. You schedule the GET, you schedule the GET, you schedule the increment, and then when you commit and execute, all the responses come back at once. One round trip. That's your performance gain. But they're not atomic. They're still being operated in order on the server side. That's important. You also have transactions in Redis. It's a similar idea, but actually transactions do require round trips. Every time you schedule a command, you're sending it to the server and waiting for a response back. The response is called a queued response. So here, the transaction is get increment, and each of them are being queued up on the server, and then there's an execute where they all execute at once. And the difference between this and the pipeline isn't just the round trips, it's also that they happen atomically. If the data can't change in between any of these two commands. And then finally, you see this in some clients, but not all clients, but Redis certainly offers it. This allows you to, an atomic pipeline allows you to schedule a transaction on the client side and issue it all at once. So again, it looks exactly like the last slide, a get, and an increment, but there's no network I/O until the final execute. And then it bursts everything over, starts the transaction, does the get, the increment, and then the execute. And it's just a more efficient way to perform a transaction. So I just want to get that out of the way here, because this comes into play as to what the whole point of this talk is about. So yeah, some ugly code ahead. It's almost like you came to a conference to go back to work. And unfortunately, it's written in PHP, and I can't apologize. I mean, that's just how it is. So, in the name of minimizing round trips, this is the kind of function that I was seeing when I came to work at the Internet Archive, unfortunately. This is just sample code. This doesn't live in our repo anywhere. But you may have seen this in your own code base, or you've been tempted to write this, or you have written it because you had no choice. Let's just say, for an example, we have a problem where we need to open a user session. A user's logging in. They have a user ID, they have an emoji ID, which is like their avatar, and there's a notifications object, which is used for sending notifications out to other machines on the network. So what do? We take the Redis object, the client object, I should say, and we create a pipeline. And then, I should add too, if you're not aware, in PHP, the $, when you see the $sign in the middle of the string, that's a variable being expanded in the string. It's just almost like an sprintf, just making sure it's clear. So we schedule a get, we schedule another get to get the name and the membership. We do a #HMGET, that's a hash multi-get, to get the details for the user's avatar, for example. And then we want to record how many logins have happened each day. So we use the date function to create a string, and we increment a particular counter for this particular day. That just represents the total number of logins that happened today. And then to create a session, we set a session key, we give it a timeout to expire in 10 minutes, but we only do it if it's not, that key doesn't exist. And then finally, we take the user and add them to a set which indicates that they're logged in. And then we execute that. Now, what's going on here? I mean, it's all kind of revolves around user sessions and user management and logins and all that. But I don't know about you, but for me, this is kind of nasty code. And it's like there's a lot of different disparate functionality that's being packed in here simply because we want to make sure that this all happens in a single transaction or in a single round trip to the server. And I should tell you, this is only the first half of the function. If you notice that execute returns a results array. So now we have to process the results. And this is the second half of that function. But I'm going to talk real quick about what's going on here. The details of the data layout in Redis are exposed. Every line of that code has to understand how the data is stored on the server. Changing the data structure means changing a lot of code. If any other code has to manage logins, or if any other piece of code needs to manage sessions, they need to understand exactly how that's laid out in Redis. So you wind up with this ripple effect that Martin Fowler was talking about. You wind up having to go through your code base and all these different little places that touches the session key or the login information. This encourages code duplication. You see this and you go, oh, I need to do that too. So tempted to just copy and paste that code into another place in your code base. It's difficult to refactor, it's difficult to maintain. And basically, my first response to try to solve this problem was, well, maybe I can just take that pipeline object and pass it around to different functions and different methods and let them schedule the code. But the problem was they need to see the results. They need to know what comes back. So then I wound up with like, oh, maybe I have a function for scheduling and then a function for processing, and it got really nasty. I'll come back to the second half of that story, but I want to show the second half of this function, which is now processing the results. So the pipeline is now executed. Now, if you notice, there's a results array that's being used to fill in, creating a user object, for example, and initializing membership and creating the emoji object and things like that. And if you notice, it's using this results array, and it's indexed by position. And so in order for you to understand how this code operates, you have to understand how these lines of Redis code were scheduled. 0, 1, 2, and then in the example of HMGET for the emoji, it's returning an array of itself, so you have an array of an array. And again, it's just more nasty, hard to read code. If you add one more command to the top of that function, you have to go back through the bottom of the function and adjust the indices of that remaining result array. Everything changes. It's just fragile, it's hard to read, it's hard to maintain. What's the problem here? It's what I was alluding to in my story earlier. Commands are detached from result processing. The result array is ordered by the commands. It's difficult to associate commands with their results. That $results 30 is just not friendly. That's not a good way to be handling, especially when you're dealing with a lot of different data, disparate data that's being used by different parts of your code base. And it's even small things. For example, Redis data types don't necessarily correspond to language data types. I didn't even handle the fact that the results might need to be transformed. For example, the string 0 is not false or null or nil or undefined or even an integer in many languages. It is in PHP, because PHP is one of the most loosest languages you're ever going to find. But a lot of other languages, they would need to be transformed. That value would need to be turned into a data type that the code can recognize and manipulate. So my problem is you end up with these big functions that try to pack everything in, again, in the name of minimizing round trips to the server. Here's the full function. Yeah, I'm the guy that walked into this, and I told myself I was not going to leave more functions like this laying around. But how do I solve this problem? In a clean world, the do everything function would be broken up into smaller functions, and each of those would be bite-sized Redis functions that are entirely corresponding to the logic, the responsibility of that particular class or module or however you break up your code. But the hard reality is that production scale requirements often require packing operations into pipelines or packing operations into transactions. And so production scale requirements often create balls of code mud. So this was the solution I came up with, and it's not an original solution. It was more like I thought through the problem and then I realized this is what I need to be doing. And they're called promises and futures, and you probably have heard of these before. I'm not trying to break any news here, but these really changed the way I code with Redis. So just a quick history lesson, promises and futures were actually first developed in the 1970s. It was sort of some work that I think that came out of IBM. They were sort of rediscovered in the 2000s for web programming. They became a very hot thing in the JavaScript world for dealing with asynchronous I/O to the server. You sometimes hear them referred to as deferred programming. The deferred means you're scheduling something and then you're waiting for the result to come back later. The big concept between promises and futures are you bind a costly scheduled operation with its resulting value upon completion. You're coupling them together instead of leaving them decoupled. The terms promises and futures, I've heard them used in a lot of different ways in different environments. So just for this talk, I'm using them in a very specific way, and I just want to make sure we're all on the same page here. A promise object schedules the operation. It's sort of like the pipeline of the transaction. That's what schedules the transaction. It's the promise being made. The promise returns a placeholder object for each operation. Instead of just returning, well, actually, in the case of a pipeline, for Redis, it returns the pipeline object itself, so you can do fluent programming. But no, in this case, it's actually returning a separate object for each operation. That object receives the result when the operation completes, and that object is a future. So a promise generates one or more futures in this particular model. So to go back to a key concept, Redis pipelines and transactions schedule work to be performed later, and then when you do an execute, you get the responses back. This matches perfectly with promises and futures. That's why I got really excited about this concept. So just to be clear, there's probably a lot of different people programming in a lot of different languages here, a lot of different environments, a lot of different clients. Your Redis client might already have support for this. Like I said, this is not an exotic concept. This isn't something new. I did a little searching on Google. I turned up libraries for Node.js and Scala. I didn't find one for PHP, however. That's why I sort of wound up coming up with this. I call it deferred. Get it, the Redis? Okay, never mind. We're moving on. But it's promises and futures for PHP. So with promises, it looks almost like coding with Redis. You create, instead of creating a pipeline object, you create a promises pipeline. And then you schedule commands just like you were scheduling them on a pipeline or a transaction. So here, we're doing a get, which returns an object. That get name variable is a future. When it does the HGETALL to get the emoji details, that's returning a deferred future object. Again, they don't hold the value yet. There's no I/O that's occurred there. But those objects are the placeholders that allow you to refer to them later. When the promises is executed, it's just like the pipeline. That's where the I/O occurs. That's the single round trip to the server. And then you can pull the values out of the named objects. So now you're no longer looking at results 1 or results 3, 0. You're looking at the get name value. You're looking at the HGETALL emoji value. That value method is what holds the resulting data. In futures and promises parlance, futures are unfulfilled when they're first generated. They hold no value. Fulfillment is when the promises object does the I/O and gives them the value. So again, it's just another term that I'm going to be using throughout these slides. So just, again, we're all on the same page. And as I've already talked about, you can use the value method to retrieve the value once the execute has occurred. So I was pretty happy with this, but I felt I could do better. And looking into promises and futures, I saw some other work out there that gave me some inspiration for where I could go with this. So one thing we often want to do with Redis is we want to normalize or deserialize the results we get. Like I said, we might want to do some type changing, or we want to maybe compose or decompose values. So futures allow for what's called transformations. So here, we're using the promises object to get the username, and that returns a username future. The next line schedules or registers a transformation. That's how you do this in PHP. You pass the name of the function. It's stirrev, which just reverses the string. So I've now registered this transformation with that particular future. Then the promises executes. That's where the I/O occurs. The username is fetched off the server and brought back, and then the transformation is executed in the background. So the username, on that last line, when the username is echoed to the screen or out to the web browser, it's backwards. The transformation is registered alongside the scheduled operation. And we'll see how this plays in a little bit to modularizing your code. Well, actually, we'll look at it right now. I'm not thinking straight. So here, for example, here's how we can use transformation to fetch objects instead of arrays of strings. The HMGET will retrieve all of the emoji information. The transformation takes the results of that and builds an emoji object. But that transformation is only occurring after the execute, which happens next. So on that last line, when the emoji returns the value, it's actually returning the initialized object. You no longer have to manually compose or decompose the values. If you notice, there's some other things going on in there too. There's a base 64 decode, because just for giggles, it's all, let's just imagine the emoji binary value, the binary image is stored in base 64. We'll see that being used in a little bit. And then multiple transformations can be registered, and they're processed in order, and that's important. It sort of creates like a transformation pipeline. So here we have a function that says the contract is you give me a promise as an ID and I'll return back a future that will give you the emoji image binary for display on the screen, for example. So here the promises schedules the HGET to retrieve the emoji image. This is the binary, or the base 64, I should say, encoded version of the emoji. On that future, it registers a transformation to decode that from base 64 into binary, and it returns the future. So that means that the caller of this function doesn't know that it's stored in base 64. It could be stored compressed, it could be stored at ROT13, it doesn't matter. The function hides that. We're starting to see now how futures can be used to modularize and encapsulate your code. But remember, no I/O has happened here. So this can be scheduled by any number of different people different callers rather, who need to perform some sort of transaction or a high performance round trip. But then, on top of that, the caller, see below this, actually calls the function, gets back its future, but then it adds its own transformation to MD5 sum the binary. So now that future will produce the MD5 of the emoji binary. All of this is happening in a modularized way. Here's another trick. This is sort of something I've found myself having to use more than once. In Redis, or Redis I should say, HGETALL returns a keyed array, or a map, which is to say if you do an HGETALL of this particular profile, you get back a mapping of name to value, name to value, name to value. But if you use a multi-get, where you name the fields you want, you get back an indexed array. So only get back the name and the value, but you have no, it's not returned to you because it's presumed that you know the fields that you've requested. So sometimes I've had to write functions where I go through HMGET for one particular code path and HGETALL for another code path. But the problem is they produce different style arrays, one an array and one a map. Well, you can use a transformation to smooth that over. And here, if the user calls this function and they provide an array of fields, the HGETALL will work as it normally does, returning a map, name, value, name, value. But the second code path, where it's using the fields to do an HMGET to only retrieve the fields the user wants, the transformation function uses the PHP array combine function, which takes two arrays, combines them together to produce a map. The point is that this future is now going to return the same style mapping no matter how it's called. Another operation is binding. Binding is a way to sort of not have to deal with these futures. You can basically, the username at the top is declared null. The second two lines of code do a get, and then the future is bound to that username. It stores a reference to the username. The next line does essentially the exact same operation, but we're doing fluent style programming, so we don't have to mess with the future. Mess with the future, sounds like a movie. Promises gets the username, and then it just calls directly into bind. The point is that in the promises execute, now username is holding the username from the Redis server. And when you're dealing with a lot of different variables, if you're loading in a lot of variables at once, this is really handy to avoid having all the bookwork of having to maintain futures and getting its values. You can just bind the results directly to the storage where you want to hold that value. And so this combines pretty well together. Here's an example where the transformation is being done, much as we've talked about before, to take an HGETALL, which is returning several fields and values, initializing an object, and then binding that object directly to the variable that you want to store it in. Transformations, there's an ordering here that's important. Transformations always occur first, transformations always occur in registration order, and binding is done last. So that way the bound variable is always the final result of all the transformations. And then finally, you can reduce several futures into a single future. As an example here, let's imagine in your application, your users have 3 different states. They can be registered, they can be validated, they can be confirmed, whatever the semantics of those terms mean. And so you have a call where you want to know, are they all 3 of those? Have they gone through all 3 steps? So you might use the sIsMember Redis call to say, is this user a member of this set, or rather of these 3 different sets, and all 3 of them produce a separate future. So then you go back to the promises object and you can reduce all 3. Now, instead of having to handle or manipulate 3 different futures, you only have 1 to manipulate, and that 1 future holds the results of the other 3 futures. It holds them in a single array. On top of that, we can perform a transformation. So the transformation converts the results of those 3 futures, 0, 1, and 2, into a single Boolean value. The point is that this future, when it's done, holds 1 Boolean. It's just yes or no. Are they or are not they part of all 3 of these categories? So I'm going to put this all together here. This is that messy function we started with. So now with promises, I can now start breaking it up. I might have a user class, and I can say get future, and this function can basically returns a future that returns an initialized user object. We're dealing in objects. We're not dealing in strings or arrays. I'm going to go through this pretty quickly because time is running short. Again, we have an emoji object. And here we can perform all the operations that are needed to initialize the emoji object out of Redis, getting its name, getting its tag, decoding the image, associating the image with the object. And then that future is now returning an emoji object rather than a bunch of strings. And here, for example, we're starting a session. And then I didn't talk about this on the slides. I knew I was going to run out of time, but there's an onFulfilled function that allows you to schedule a function to be called when the future is fulfilled. In other words, when the future receives its final value. And here, this onFulfilled is scheduling a lambda, an anonymous function, to call a notifications object and let whoever is listening know, yes, a user has opened a session. And so this is now the full function. That old crusty old function, I haven't gone through and shown all of the refactorings, but it essentially works like this. Get the user, get the emoji, and using onFulfilled, you can set the user's emoji in line. You don't have to wait for the execute to finish. Start the session, notify the login tracker, set memberships, you hit execute, return the user object, and you're done. And all of that code that was before, all that Redis manipulation and Redis scheduling has now been packed away into different classes, different modules, and the places that know how to deal with that data on Redis is where it's located. And if you're interested in this library in any way, this is where it's at. It's up on GitHub. It's open source. Do whatever you want. Fork it. Don't. I hope you do. The point, this is sort of at the time where I'm supposed to do like a call to action. Like I'm supposed to say, here's what you should do. I'm not trying to sell you on this library. I'm trying to I'm setting up a flare. You don't have to write that nasty, ugly code. There are other ways of doing this. And I know that this is out there because I've gone into I've seen other people blogging, and I've seen other source code that's out there, and I could see a lot of different people trying to work around these types of problems. Solutions are out there. I think promises and futures are an interesting way to solve this problem, but there are others. I do hope if you do have any interest in using this library, you give it a try, and let me know what you think. Any questions? I know we have a microphone, but
Slides, are they going to be available?
yeah, actually, I'm going to put them up with the GitHub.
Is the transformation done on the server side or the client side?
The question was, are the transformations done server side or client side? That's all client code. The transformations are purely on the client.
To get the values out of the HMGET operation, you still seem to know what result 0 would do, what result 1 would do.
Yes, so the question was, when you get the values of the HMGET, you still have to know the 0, 1. You still have to know the indexing. Yeah, that's unfortunately just the result of at least how the Redis client works. I've thought about ways to try to work around that. There might be a way to do that. But generally, I think what I like about this, though, is even though that still exists, the result processing happens right where the command is scheduled. So it's very easy when you're looking at the code to realize 0 is this field, 1 is this field. What I don't like are those big, long functions where, if I have to scroll up and down to figure out what is connected to what, I know that there's going to be a bug. So.
How could I use these same concepts since I code JavaScript?
So the question was, how can you use the same concepts with JavaScript, the same ideas? I'm not the guy to ask for when it comes to JavaScript specifically.
There are promises, but I've never heard of a binding to a future.
Yeah, well, so this is just my terminology. And I don't know if, well, for one thing, I do know that I found a promises library for Node.js that was tied to Redis. I think part of the issue here, is I don't believe, there might be a way to use a generic promises future with, or promises library, I should say, with Redis. But I think the peculiarities of Redis are such that you really want to be finding one that's designed specifically for working with Redis. And I don't know that area that well, but I know of at least one. Like I said, Node.js offers something specifically for Redis, and I wouldn't be surprised if there were others out there.
Is there a Java integration available for the same? Is there a Java integration available for the same?
I don't know. I'm not familiar with them. I think I found one for Scala and Node.js. I didn't go digging that hard. Mostly I was looking for, is there a PHP library? That was sort of my problem, and I couldn't find one. So again, I suspect if your language has libraries or language support for asynchronous programming, inline functions, lambdas, that kind of thing, I suspect that something like this could be cobbled together pretty easily. Let me put it this way, this library I built, I think it's about 500 lines of code, and that might be including the comments. It's really not a whole lot of code to get to where I got with this. I think it's mostly the concepts that are paying dividends here.
Do you support some of the Redis cluster APIs?
No, it's just, to me, the library is just plain vanilla Redis. So now with Redis, you can configure it for Redis cluster. At that point, I don't have much experience with the Redis cluster stuff. So if you try it out with Redis cluster, I'd be very curious what you find. Well, thank you for listening. I appreciate your time.